thank you for having me. This is my first time here at PyCon. It's been very nice and pleasant so far. Everyone's very nice, so I'm very excited. And I think we need to spend a couple of minutes on clarifying what I'm talking about here, because a lot of people asked me yesterday, is it something with Twisted or is it something with Tornado, or what kind of networking type of things are you talking about here? It's not. I want to give you an idea of what network engineers do who work on big-ass routing equipment. So when I talk about networking, I'm thinking things like BGP and PLS, that kind of networking thing. There's surprisingly a lot of libraries in Python that talk to networking equipment that we use as network engineers on a daily basis. So that's really what it's going to be about. Okay, a little bit about myself, because I have not been here before. I used to be a network engineer. Really, today I'm kind of probably doing more of those things that you guys do on a daily basis. That's why I kind of set out to go to conferences like this a little bit more and less to the networking type things, because I've heard a lot about BGP and I kind of know how it works, but doing the programming things on a daily basis, I actually have way more in common with you guys on a day-to-day work basis than with anyone else at my work. So that's why I'm here, really. I started this whole thing as like plugging in cables in a data center at the Amsterdam Internet Exchange sometime in 2005 or so. It's been a good 10 years by now. I lived in Amsterdam for a while, and I've been really lucky to get remote gigs ever since. So I'm sitting at home and hacking away on my couch on Python tools for the most part. Let's see what else. Yeah, I have a couple of projects on GitHub and stuff, mostly networking related, so if you want to check those out. And then as a hobby, I do sailing things that are the last link there. If you've ever been on a boat on an ocean, that's kind of fun too. Okay, so network engineering. What do we mean when we're saying network engineering? I deal with things like Ethernets and VLANs and ACLs and routers and switches and OSPF and ISIS and all of those things that are, they're all kind of protocols, they're all defined somewhere, all the routing equipment talks to them, but my main concern in this whole thing is they need to be set up and configured and managed somehow. And there's network engineers out there whose day-to-day job is to sit there and type on those devices and make sure there's no inconsistencies and make sure everything is configured right. Those devices are literally like, when you think switch or router, you're thinking like, that size box. I'm thinking like this size box. They're taller than me. You need 4 forklifts to put them into racks. You spend days and days on plugging them in. It's not very glamorous to sit in a data center. It usually looks like this. You're on the floor crawling between cables or under floor tiles if you have to. I was always the smallest one in the team, so I always had to get under the floor. That was not really nice. It's very noisy too, but then again, I don't know, if you compare it to programming every day, it was easier in a sense that it's kind of brain dead work and you don't really have to think a lot. So you like plug in music, go to a data center, put the big headphones on, and you don't have to think about it. So yesterday I had this day after the first day at the conference. It was kind of hard. We had a bit of beers there, and had a tough time yesterday. So for a day like that, sitting in a data center plugging in cables is actually a really good thing to do, versus when I sit on my computer trying to program something, it doesn't really go that well at that point. But yeah. So those routers, you log into them, you change things on the CLI. There's a lot of manual stuff involved because the network configuration is not very stable. It changes a lot. You turn up new connections, you turn up new peers, you turn up new links. Mostly those links are to, if you know a little bit about data center networking and you put in a top of rack switch and you control all the ends of the connections, everything is fine. If you're talking about networking in a sense of AS numbers and interconnections between networks, you're working with a lot of people, making sure your remote link is up to some other company, making sure the BGP session with them is up, something goes wrong, how many prefixes do they announce? Do they even announce the stuff that they're allowed to announce? I don't know, one of those famous news, we don't have that many interesting things going on in networking, but one of those famous news things was when someone in Pakistan hijacked YouTube's IP block a couple of years ago, and then everyone went, ah, and all the YouTube traffic went to Pakistan, and everything was a big deal. So those kind of things can happen when a network engineer mistypes something on all of those routers. And those routers change a lot, because you, if you work on the bigger size of equipment, which I was set out to, you're usually working on like the newest release of the newest hardware with the newest software, and it's mostly still in beta, and you don't even know if it's going to work at all. Or you're working on old equipment that is not supported anymore, which was really, really fast in networking. So you never have a situation where something has been on the market for a while and is stable. Things change every other year, so it all is a little bit meh. Okay, before we do anything else, any questions so far? No? We don't know? No. Okay. Okay, so this is network engineering. So now what do we automate in network engineering? We have a couple of things to automate. They all don't sound really hard, but the environment makes it really hard because there's not many standards around that make sure you can use that stuff. So we do telemetry things. We want to see graphs. We want to see, and it's mostly as easy as a graph over there. You want to see your traffic going in and out of devices and in and out of different interfaces. Maybe divided up by what other companies it's going to, what other peers it's going to, etc. That's about what you have to graph. You want to monitor state, so you want to be alerted on interfaces going up and down, on sessions going up and down. You want to troubleshoot things, so if something is wrong, be able to figure out why and where. And typically, an engineer goes there, logs into the particular device where something went wrong, types and types and types, and gets a lot of output, and eventually figures out what's wrong where. But that costs a lot of man-hours for people to be able to do. So we've been trying to somehow automate those things along the way. And then another thing is provisioning. There's always a lot of provisioning going on, especially at bigger companies. They're always in some form of growth phase. So you basically end up installing new boxes every week, and you need to make sure they're all compliant. You put up new servers somewhere, and you want to make sure they fit into your entire cluster there. And now everything is in the cloud these days, and we're doing, for server type stuff, we're putting it in the cloud too, but routers we can unfortunately not put into the cloud. At least not at those speeds, I guess. You guys may have set up like a router in AWS or somewhere before, which is, do application type routing, like Matthew was talking about yesterday. Routing. I know, I always find it funny when people say routing and then wait, it's not BGP what you're talking about. Apparently not. Yes. So those big ass boxes have, we're talking about interfaces of like 10 GB, 40 GB, 100 GB. You don't really do that in a software router in the cloud anymore. You actually need close to the hardware equipment to be able to do that. So if you want to do those things and you want to automate your network and you actually have people that know how to code, you might be Facebook, and then you end up with something like this. And this is their tool set for the networking team. They actually have a team of like, I don't know, it's a bunch of people. I know at least 5 people that work there, so the team must be more than 5 that solely work on software related to networking. And from the names you can kind of gather it as like, you do things like you want to drain a router and like reconfigure boxes to route everything through a different through a different portion of your network, to be able to replace stuff, to be able to upgrade stuff, etc., etc.
What is Megalon?
I have no idea. That's what they called it. Some weird name for whatever portion. We have names like this. The project I'm working on right now, we have names like this too. We make up fun code names for things. They gave a presentation about kind of their alerting setup a while ago at one of the networking RIPE. It's one of the bi-yearly networking meetings in Europe that I go to on a regular basis. So that's what Facebook presented. Now, unfortunately, not all companies have a team of 5, 6, 7 people that can work on this stuff every day. So there's a lot of enterprise-grade equipment going on that will actually provide you with software, which is, you know, you will get the enterprisey interface that you can click and do a couple of things. With the support contract with it, that costs you the appropriate amount of money if you want to have it. So typically companies that are working with core networking and are really small or are really, really big tend to do their own things with homegrown tools and homegrown software, etc., etc. If you're a mid-sized company that can afford the enterprise solution and you just buy it and get the support with it, you'll probably end up doing that. If you're really small, you can afford it. If you're really big, it's going to be cheaper for you to hire a programmer to actually work on this stuff. Internally, it's going to be way more adjusted to your workflows, to your scenarios, to whatever you want to do in your network. So you end up hiring people. And then they have to deal with things like, and this is really where we get into the PyCon soon here. So every router, and it depends on the vendor that you're using in a network. You can use a single vendor, you can use multiple vendors, provide access to their devices somehow. Now each of them has a different OS, and it's literally like each of them works differently. You cannot really go and configure a Juniper router the same way you're configuring a Cisco router, because it has a different OS. It works completely differently. So the first thing you kind of have to assess, okay, what are those OSs that I have in my network, and how do I connect to them? Now, usually, traditionally, you do this on the CLI. You know, people are used to, they log in, they telnet into their device, they do line, and then something happens, and then a while later, SSH came in, which is, no one really telnets into their devices anymore. People SSH into their devices these days, but it's still line-by-line configurations, and they're not transactional, and it's really hard to do any programming around it when you have to make sure that every line of your configuration goes through and kind of catch the errors along the way. How do you even you paste in 20 lines of configuration, and after the 10th it breaks? How do you roll back? How do you make sure you have a consistent state on your device at that point? That was really hard. So that's kind of the thing that we've been working on for a while now, trying for different networks, for different vendors, trying to figure out how to deal with those situations. So the different OSs might have configurations that look like this. I hope you can read that over there in the back. Well, you don't really have to read it. You see that the syntax is different, right? That's kind of the main thing. Compare your Apache versus Nginx configuration. It kind of does the same thing. It will set up an HTTP server. The file will look different. The commands will look a little bit different, but it's going to be the same thing. The difference to stuff like that, our configurations are unfortunately much longer. I checked out a router that I have at work right now, which has like 3,500 lines of configuration. So that's the sizes that we're kind of dealing with, and the configurations they hold a lot of policy and business logic, because all the interconnections that you do are business relations, right? So you peer with someone and you agree to exchange a certain amount of traffic with this peer and with that peer, and you have limits and you have minimum commits and you have maximum commits, and you cannot do more than that traffic to them, etc., etc. And you reflect all of that in your policies, in your configuration. So, there's the manager, businessy type of people who make the deals with the other company and then come to you and go like, hey, so can you set it up this way for that particular person and a different way for that particular person? So there's a lot of ongoing change going on a day-to-day basis. For another example of how it differs, so this is me adding a BGP session on a router. On a Juniper, it looks like on the left. On Cisco, it looks like on the right side. How do you write scripts to do that, right? It's like, they could have thought this through a little bit more. And they tried and they do. So there's netconf now, and we're all very happy there's netconf. Netconf works on top of SSH, but it allows you to make RPC calls to the devices. which you can XML format commands into. And you also get XML as a return, so that allows for transactions, because you're going to give it an entire config block instead of line by line on the CLI. It's going to know if something breaks, it's going to throw out the entire block you give it if you have to. We also need to retrieve data from the devices. In XML, you get structured data, which is so much nicer. It gives you some form of error reporting, etc. So all of this is really nice. The problem with this entire netconf thing is there is an RFC, and the transport is kind of clear, and everyone has implemented the transport in that way. The problem is not everyone has done all the details exactly the same way, so you can use netconf on a Juniper device and it will work perfectly, and they will have 100% of the configuration covered. You can retrieve every single bit of information from your device from a Juniper. Try it on a Cisco. You might be able to connect to it and do like one command via netconf, and they don't allow for anything else. So the discrepancies of the implementations are huge, and it's really, really annoying to have to deal with that. And you can't just grab a netconf library and be like, do this on that router, and it's going to be the same thing, because it's not. And next to like, some people probably, it takes a long time. We've been trying to use IPv6 for so long now. netconf is in the making for the past 10 years as well, and it's still not really there. So it's really hard to introduce change in this environment where, those routers might have been set up 10 years ago and function the same way and are out of life by now, and the company can't afford to buy a new one, so they just stick to the old device that doesn't support the new technology, because why should they? And, there is a lot of mixing and matching going on. Okay, so I was talking about retrieving data, which you want to do. So you want to know the state of your network. To know the state of your network, to see if links are up, if BGP sessions are up, you have to look at operational state data on your router. For example, I want to see what ARP entries do I have on my router. I need to run we call them show commands. I run my show commands on my router, and I get output like this. Or this is on an Arista device, or I run the same, similar show command on a Juniper, and I get output like this. Yes, we do have to parse this, and I spend a lot of time writing regular expressions, because there's no other way to do anything useful with this data other than split it up line by line. Also, if you didn't notice, there is on the Arista example, there is an H timer in minutes for when it recorded that ARP entry. On a Juniper, it doesn't even have that. So the data is not even the same. If I wanted to build a database and pull all my routers and put all the ARP entries from my entire network in that database, how do I do this consistently if I have a network with Arista and Juniper going on? It just sucks. So if I would use netconf for this, and not all routers support netconf to even be able to do show commands, on a Juniper I'm happy and everything is great, and if I do that on a Juniper I get XML back, and then with XML I can already do something, so it's not that bad. But there's a lot of, you get shown here to it's very annoying. Mostly you're just shouting and screaming, and yeah, so in the very, very early days, and I spent a lot of time working with libraries like expect and Paramico, which is an SSH wrapper, because those were kind of the only ways you could connect to those devices, and you would be stuck on your CLI, and you would run the show commands and regular expression your data out of them, but this is kind of all you could do. There is NC Client, which is a netconf library that we use. So, network engineers sit there and try to figure out how to code, and then use expect, and then match on whatever prompt your router has to return, and then things go wrong because the returns. How many of you have used expect before for something? Okay, it's annoying no matter where you do it, right? So, so this is really, yeah. So Paramico, which lets you connect via SSH, is great, and the same really with NC Client. Unfortunately, the routers differ in a sense if you connect, I think it was one particular version of HP devices, if you connect to them, you have to send an additional escape character after you're connected to your SSH, etc. So you couldn't even use Paramigo because it wouldn't actually recognize when your SSH session was there. So there's all those little differences that you stuck on, and you actually want to, you actually want to think about how to configure your network and not how to be able to access your device. It gets, okay, one more thing on how this gets really annoying. There's things like they literally, it doesn't work, you go on call tag and you're like, okay, something is broken, how do I fix this, why is my config not loading? And they tell you, oh, you should remove the comments from your configuration because something in your comment doesn't escape. How can something in my comment not escape? I mean, seriously? they do things like this. This is, by the way, fun, really honest networker. WordPress is a very funny meme blog on the kind of things that we deal with on a daily basis. Okay. Things got a little bit more exciting when Python became more and more interesting, so people were using the paramigos and pexpects, and then vendors were like, okay, for the people who actually try to like home grow their solutions, we're going to help them a little bit, and dedicated a person or two to actually write libraries. Well, some dedicated a person or two to write libraries, some didn't, and then we ended up writing them themselves, ourselves. A few just because there's more out there, but I work with Juniper devices right now, so I'm in heaven, and it's really nice, and they have a really good library to Python to them. They actually do full netconf in the first place, so it's really easy to deal with that. In a previous job, I had to work with iOS XR devices. They had nothing for it, and their netconf implementation really sucked, so we had to write something ourselves. This is still a library I try to maintain every once in a while, but I haven't had access to. It's really, so this is another thing when you write open source for networking devices. I have not had an iOS XR device for over a year now, and I wrote this library back at a job, and now I'm having trouble maintaining it because I don't have any device to connect to. And then sometimes they give you virtual boxes, and you can like connect to a virtualized routing engine. But it will differ from what the actual device does. So it's like, okay, not really able to do that. Arista has a great API on their devices in the first place, and they provide a library to connect to that API. So that's really nice. Let's see, anything else interesting on those? Okay, so then you have, if you're lucky and you have one vendor in the network, you pick out the library that supports whatever network vendor you have there, and you use that. And then if you're not lucky, you might have a mix of like, I have Aristas in my data center, and then I have Junipers as my core routers, and then I have some other switch somewhere, and then you end up with a mix of those, and then you're trying to connect to all of those at the same time, which is where multi-vendor libraries come into play, really. The idea being, let's see, I'm trying to come up with an example from the server world, really, can't really think of anything. I don't know, you can have servers, you can have servers with different operating systems, right? You can have, I don't know, your Ubuntu servers and your CentOS servers somewhere, and you want to maintain them kind of out of the same tool set, because you don't want to have a separate tool set. Here's everything from my Ubuntu, and here's everything from my CentOS, right? So you're trying to have something that you can access all of the devices you have in a programmatic fashion. So Paramigo has those little differences where like you need special escape characters to be able to connect to your shell, etc., etc. Kirk Byers with NetMeepo on top of that, which deals with all those annoyances. So you can do SSH connections to networking devices reliably, even if their access is somehow weird, through NetMeepo, which makes life very, very easy, but you're still on the CLI. And then about, I guess it's been a year and a half, maybe 2 years ago now, a friend and I were looking for a way to automate our multi-vendor networks. We had the same vendors in the network, so that was kind of nice. And we were like, hey, we need to write something to figure out how to do all this out of one tool set. So we wrote Napalm. Well, we started Napalm, and then as every open source project, it kind of grows out of proportion over your head at some point. We started that with 2 people, and now kind of 20 people contribute to it, which is really awesome, and a lot of big companies started using it in their network. Like, my friend David, who started this with, was already working at Spotify at that time, so that was already pretty cool. And then some guys from like Cloudflare started emailing us, and Cloudflare has their entire network backbone based on Napalm these days. So I'm like, hey, this is pretty cool. So what we did with Napalm, it really uses the network, the vendor libraries. So it uses things like PyEOS and the Juniper library, etc., to simulate the same set of commands on every router you can connect to. So it supports about 10 or 12 vendors these days. People start contributing modules to it. It uses netconf where it can. When it doesn't, it does something similar to mimic it. I thought it was a very cool idea. So on Cisco iOS, there's no way to do netconf whatsoever, and we were trying to find something that at least provides transactional access. And then Kirk, who wrote the NetMiko library, came up to us and he was like, hey, why don't we just SCP a file? And in fact, you can do that. You can SCP a new config file, try and load it, and if you get an error loading it, the old one still stays intact. You have an error somehow, and you can SCP something else. So we mimic netconf or transaction support through SCP. I know it's weird, but those are the kind of things that we have to do. So yeah, there's a question.
Yes, there is a question. Do the enterprise routers support SNMP protocol?
Yes.
Can be configured that way?
Yes, they do. I'm trying not to use it at all. Do you guys still do you use SNMP? Well, I guess on servers you use SNMP to pull for like network interfaces. The problem with this is you don't know who asked the question. Who do I talk to now? Yeah, so we do support SNMP. The problem is SNMP is very, very slow. So if I have a networking device this tall with about 512 10 gig interfaces and I'm trying to pull all of them, it can take your 25 minutes or so to get all the input of that, which is a little bit annoying. It's unreliable because it sends data, sometimes you don't get it, sometimes something goes wrong. I'm trying to stay away from SNMP. I'm actually, let's go one slide further, I'm gonna mention that a little bit. So I redid those slides a little bit yesterday because we had a very lively conversation about microservices the other night. And this is the network I'm working on right now. Which is not much of a network anymore. Well, the blue round things over there is still the network, and then other than that, we're actually trying to manage and maintain that from other tools. Let's see. Okay, so routers do syslog. That's the one thing they do, and we just collect syslog. I set up Graylog, and we're trying to, just have something to be able to view and select and search in our syslog data. So that's really nice and that's easy. And then yes, this is all with the caveat that I do have a Juniper network and I can do full netconf, so things go very easy. So when we sat down to, and then I was very lucky to get into a project. I've been hacking on this for the past year or so now. That was a new provider who set up a completely new network, so I had a completely greenfield environment to play with. Typically you come into some network shop and you already have scripts that do this and scripts that do that, and you kind of have to integrate it all into one tool set, and there was nothing there. So we had the opportunity to sit down and design this kind of the way we wanted to, which was really nice. So we kind of came up and we had a conversation here, a couple of people, to do if we should do monolith applications or microservices, and we kind of sat down and we were like, okay, we have so many independent things going on, the microservices make sense for that. So we built something. Let me go through this a little bit. So we built something that, okay, we have an upper right. We have a laser pointer thing here. No. Never mind. Upper right, everyone here knows the logos, right? If I would show that at a networking conference, everyone would be like, what is all this stuff? So we have a TSDB to collect all kinds of time series data. and it gets messages. We have a message client, Rabbit, and we have little services that take data in and out of the device via netconf. So we have pollers that pull data, pull it onto the Rabbit queue. Another microservice kind of listens for, is this destined to be a metric in TSDB, throws it into TSDB. Another one is, okay, is this the data that I have to cache, and it throws it into a Redis database for caching. We have a typical, and this is where you guys kind of work, API and front end and customer database going on. Where I get service provisioning from, so like a new customer signs up and the database says something and provision a new circuit from here or there or blah blah blah. So it will put a message onto Rabbit, that will pick it up with my little listener and then GoNet could generate a configuration and then GoNetConf configure that. We use Ansible for device provisioning, so you have the services that you configure for kind of different customers and peers you have. And if you set up a device, there is a lot of default logic going on that you want to set up on like either new data centers or new devices, etc. So we use Ansible to generate and template our base configurations. And if you have like OSPF or ISIS, you typically have a full mesh of sessions going on between your routers somehow, so they talk to each other, which needs to be set up kind of initially when you take the device into production. So all that we do out of Ansible. Yeah, this has been a really fun project. So see, this is how I kind of do the things right now that you guys do on a daily basis, but yeah. We use Jenkins to CI and CD all of this, so we deploy all of this automatically. We got it integrated into Slack, so I can like go into Slack and say deploy my master from somewhere, etc. It's all really cool right now, so I'm very excited. Other things that we're going to have in the future, which is, you know, well, in networking it's going to take another 5 years or so, but people are talking about things like streaming telemetry. So instead of, so SNMP, what I wanted to say about SNMP. So I'm omitting SNMP here completely because I don't really want to deal with it. And I'm using netconf to retrieve all the data that I want to have from the device. It goes much faster than SNMP. The other problem is SNMP only has a very limited subset of, you get interface counters, but if you, for example, want to get a, let's see, a counter of a particular VLAN interface, so that's a kind of a sub-interface on your actual Ethernet, they don't provide that in SNMP, right? The standard doesn't have the fields, so you still would have to have other means to log into the device and try and get that. So I threw away SNMP a long time ago, and we're getting everything through netconf right now, which is okay. They talk about that eventually they're going to provide you with like a proper pub/sub mechanism and actually publish telemetry out of the devices. But as with every vendor, and the question is always going to be, the first question I ask them if they talk about, you know, oh, we're going to have like streaming telemetry, what fields are you going to support? And then when they show you the roadmap, they're like, oh yeah, we're going to support those 4 interface fields in the first version, and then maybe in the later version this, and maybe in the later version that. So for all the data that I actually monitor on a router, I'd have to wait for another 1.5 years at least before it even goes into the pipeline for the vendor to work on that. So let's see how we're going to get there. They want to package it into protobufs, so that's another thing that I'm kind of looking at, see how to retrieve protobufs once all of that happens. It's gonna be a while. This is, you know, job security and networking. Using Ansible. Yes, there we go. So we use Ansible, Napalm, that multi-vendor library that a friend and I wrote a while ago, has Ansible libraries that we wrote out of the box. So you can use all the vendors that are supported through Napalm, you can use out of Ansible. And then ever since Peter used to work for Arista, and he joined Ansible about last year sometime, and he is responsible for kind of the networking section of it, and they wrote a lot of libraries for a bunch of different devices. They differ, I think they differ in a sense. I don't think they're transactional, but don't kill me if that's wrong. And they do a library per vendor. So you would have, in your playbooks, you would still have to know, am I talking to a Cisco, am I talking to a Juniper, and you would still have to write your playbooks according to what device you're talking to, versus like if you would use Napalm Ansible module, you could just connect to any device with the same commands and it wouldn't really matter. Except for you would still have the particular configuration syntax, but that's another thing. Okay, do we have any other questions? That's about what I have.
Yes, you already answered the Ansible one, but there is, can you please recommend the library to access TP-Link managed switches? Cheaper
Yeah, TP-Link managed switches. Cheaper vendor, I have no idea. Do they support Netcom? Probably not.
No, you cannot use this on TP-Link managed switches. Do not use TP-Link managed switches.
Yeah, do not use TP-Link managed switches.
No, I'm serious. No. I mean, you cannot use this mostly because TP-Link has a lot of bugs with the firmware, and always kind of surprised because they out-Ciscoed Cisco. You have a happy path that you have to follow in the web UI. So if you remove a VLAN and add a VLAN, it's not the same. You have to basically visualize the device and configure it again. So it's really horrible. You do not want to use those.
Yeah, but you know, if you're a network and you can't afford anything else, you're just making do with whatever you have. So if you have to use that, I'm very sorry. That's probably all I can say.
Yeah, there is one more.
The Ansible one we have? Okay, test configuration before commit. Yeah, that's a good one. That's kind of the thing I'm struggling with a lot. It really depends on how your network is built and what you have. So it helps a lot if you template your configurations, because it's already like, you know, you cannot do a lot of typos if you have if you have templates that generate the stuff that you need to generate, which is kind of how we're trying to get away from it. There has been an instance or two, I've heard from a person or two who wrote something that is kind of similar to unit testing for your configurations, but I think anything other than like syntax validating it, they can't really do, right? I mean, we cannot have we cannot do like a green-blue thing where we have a second network that is identical to our first network where we roll out configurations. I mean, the best thing you can do is syntax tracking. You can load it onto a lab device and kind of see if it works, but you won't get the actual, like, you know, prefix announcements, etc., you won't see, so you can't really do much with that. So yeah, syntax, using unit tests to syntax check your config portions is kind of the niftiest thing I've heard so far.
And one more thing, what do you use for visualization?
Well, right now in the example at the end, we put it into TSDB and we have our own, like, we have a front-end team, so they just wrote something in like P3 or whatever and we display our own graphs. There's out of the box, there's like, if you look at a network and you see an MRGG graph, you're like, oh, they haven't worked on this in like 10 years probably now. If you look at it, they can have, if they have cacti, they might have changed at some point. People set up Grafana these days. There's people who use Elk for things. It can get really complicated if you do S-flow, NetFlow analysis. It can get pretty complicated because the amounts of data that you're getting are huge, right? Try to monitor a 100 gig link. I mean, there's a lot of shit going on. So you sample it down, you use NetFlow and S-flow to kind of only sample traffic, and then yeah, graph things in that. So use funky libraries for like S-flow and NetFlow monitoring.
Okay, another question. How do you handle different abstractions from different vendors? Like, for example, on the firewalls, you have FortiGate approaching the policies from one side, and, for example, I don't know those SRXs doing it in another way.
Yeah. You have to know the ins and outs of your vendor. So, because in the end, you're going to be the one who writes the templates for your configuration, right? If you know that in advance, you template it in a way that it makes sense. Typically, when things like that happen, I'm trying to abstract it for. See, this is where the hard part comes in, because the network engineer who uses the tool that I write they know that those are the gotchas, right? And they're like, if you change it for them, they're like, hey, but this device, I typically configure that differently. So when I try to, like, I make a template and I have them give me input that then turns it around, they're like, but wait, I wouldn't do that with the device. So you need to stay very close to like what the original hardware supports for the network engineer to be okay with your tooling, because they're used to like log into it and be like, oh, this is how it works, and that's what it does. So yeah. White box devices, in-house firmware, SDN. Okay, let's talk about SDN. Is that your question? No. Okay, so let me get into that first, and then, okay. Yes, people do that. The problem is that a lot of companies struggle with simple things like this, and they don't even have the means to, like, you know, how can you talk about programming your actual routing flow when you cannot even automatically get configurations onto your device, right? You need some form of tooling already for your network to be even able to like think about. There's people who do that, and actually David, who I worked on Napalm with, did a very, very nifty thing at Spotify, where he was actually like programming routes into his devices directly based on, but you need the tooling to be able to do that. So he was getting data in from NetFlow, doing analysis on that and figuring out what routes his device actually need in that particular location to only program those particular routes. Maybe the gotcha here is if you get a full routing table, you have, you know, 200K or whatever it is right now prefixes, and routers actually have trouble calculating, like if they're trying to get a packet, calculate the best path, use that prefix to send your data out. So what he did was he used devices that are not able to buy a small, like Arista switch. They typically don't support a full routing table, so you use like Cisco, big ass Ciscos and Junipers to be able to support full routing tables, or multiple of them, because they typically have a couple of uplinks to a couple of providers. So he did something where he was using a small, tiny pizza box Arista switch, figuring out from NetFlow data what his biggest peers are, and then programming only those routes on his Arista. That's kind of the extent of SDN that we've been doing. That is very similar to what Google and Facebook are doing as well. I mean, most of their SDN, as far as I know, goes actually on in the data center, where you don't need that much, you know, where it's not the full, like, this is not my core router situation. It won't replace the core routers, and if people are still struggling with configuring basic features on their devices, how do they do SDN? Okay, that's my rant on SDN. Next.
Okay, so you mentioned the issues with rolling back to the original configuration if something goes wrong, right, during the configuration process. So how do you deal with this issue in your framework?
So, it really depends on the vendor. If you have netconf, it's easy, because if you configure it via netconf, you will get a transaction, it will not make it, it will not let it through if it fails somewhere along the way. If you're using the CLI and you have to, like, line by line, you literally have to write scripts that, so typically on a networking device, if you want to remove a line, you have to do a no in between, so you do like IPBGP neighbor or something, or if you want to remove the neighbor, you do no IPBGP neighbor. If you have to do it by hand, you actually have to make sure you know which commands went through, and then if halfway it failed and it didn't, run the corresponding nodes to remove the configuration again that you tried to have to keep it in a consistent state. It sucks. I know.
Alright, that's all, no more questions. So, thank you for your talk.